So for those of you who are studying navigation and particularly plane and Mercator sailing, some of you may be struggling to memorize the formulas, especially if they are not given to you in the exam. I'm not sure how the system works with you guys, but I thought I'll make this video today to teach you a few tricks, just a few simple tricks, or maybe you can say they are like triggers in your memory that will help you to memorize the formulas that you require for plane and Mercator sailing. It will not help you to memorize, but it will help you to be able to derive these formulas on your own if you get a question in the exam. All right, so I'll take an example in that in the same spirit here, and I'll show you what to do in the exam if you get a question in plane or Mercator sailing, and how to derive the formulas if you are not given them by your assessor or by your examiner. All right, so here the question is that you have to find the course and distance between position A, which is like the departure position, and position B, which is the arrival position. Alright, so you have been given these two positions, and now you have to find the course and distance between it, and you have to use the concepts of plane sailing. Alright, this is what the question says. And now, for example, if you have not been given the formula, now you are struggling to remember the formula, or you are not very sure, so how do you go about deriving the formulas yourself? So basically, firstly you have to plot the positions. All right, so you start with your departure position. You can plot the departure position somewhere here. All right, the horizontal line is the latitude, the vertical line is the longitude. Just plot it anywhere on a sheet of paper, and you say this is my departure position A, this is 27 degrees 11 minutes south, and 090 degrees 25 minutes east. All right, and now you have to plot your arrival position. So to do that, you have to look at your arrival position. In this case, it's 15 degrees 23 minutes south. So it means that from 27 degree 11 minutes south, you have to go to 15 degrees 23 minutes south. So you have to go northward, because if you are in the southern hemisphere, if you go north from the southern hemisphere, your south latitude will decrease. Yes, your south latitude will decrease in value, right? And if you go southward from a southern latitude, if you go south from the southern latitude, your south latitude will increase. So now you know that you have to go 15 degrees 23 minutes south, so it means you have to go northwards. You are not supposed to be going southwards, so you have to go northwards. And then you look at the longitude. So from 090 degrees 25 minutes east, you have to go to 115 degrees 34 minutes east. So your east longitude should be increasing, right? So your east longitude increases if you go eastward. When you go eastwards, your east longitude will increase. If you go westwards, the east longitude will decrease, correct? So you have to, now you know that you have to go north and you have to go east to reach your arrival position. So you will go north and east somewhere on this track here, and say this is position B. You have marked position B as 15 degrees 23 minutes south and 115 degrees 34 minutes east. Alright, now here is the arrival position. The line joining these two positions become your distance. This is the distance your ship has to travel to reach position B from position A. Now you have to understand the course. So if you are going north and eastward, that means your course has to be northeast. Now all the courses are measured. They are measured from the North Pole. So the courses will either be measured from the North Pole if you are going on a northeast and northwest course, or they will be measured from the South Pole if you are going southeast or southwest. So because you are on a northeast course, yes, you will measure it from the North Pole. So I will draw a perpendicular line, and this denotes the north, right? You measure your course from the North Pole. This is the North Pole. Measure your course from the north, and this is the course. All right, now ideally these should be, I will draw this course again just to make it simpler, so you know exactly. This is better. All right, so your this theta here is your course. Course is denoted by the symbol theta. This is the same famous Greek symbol theta that denotes the course. So now you've got your course and you've got your distance. You have to mark the other sides of the triangle as well. So how will you mark the other sides of the triangle? I'll use a different color of the pen. Now the horizontal line, like I said, is the latitude of B. The horizontal line here is the latitude of A. So the difference in these latitudes will of course be called d-lat, which is the difference in latitude, right? Because the horizontal line is the latitude of A and the horizontal line is latitude of B. So the difference in the latitudes is the d-lat. D-lat stands for difference in latitude. Now that is the vertical distance. The horizontal distance between A and B is known as departure. Alright, so often a question I get asked is, why is this not d long? Now I'll explain this to you why it's not d long. Alright, now in plane sailing we assume that the earth is flat. Alright, the earth is flat and it works for short distances only. Now of course we assume in plane sailing, so when we say plane sailing, we assume that the distances between latitudes, if these are the horizontal lines are the latitudes, the distances between the latitudes are equal, they are the same. So if it is 10 degree north, 20 degrees north, 30 degrees north, the distance between them is the same. That's why if I draw a plane sailing triangle anywhere in these latitudes, the vertical distance is always the d-lat. However, when it comes to meridians, the meridians are not drawn as parallel and perpendicular lines, they are drawn as converging and diverging lines, just like you see them on a globe. On a globe, the meridians emit from one pole and they join the other pole. So the horizontal distance between them is not constant. You can see that it's not constant. It's more increasing, it is more here and less here. So as you go towards the equator from the poles, if I call this North Pole and South Pole, you can see that the horizontal distance is increases from the pole going towards the equator and then again decreases from the equator as you go towards the South Pole. So that's why we cannot call them d long, because the distance is not constant, and that's why these distances are called departure. Alright, so that is why you don't have d long in the plane sailing triangle. Now from this diagram here, once you draw the diagram and you have seen the course and the distance and the d-lat and the departure, you can now derive the formulas for plane sailing. So the first formula would be, let's say, cos of course. Now cos of any angle in a right angle plane triangle is always equal to base upon the hypotenuse. That's the cos of any angle. Now in the above triangle, you can see the base of the angle theta is d-lat, that is the base of the angle theta. The hypotenuse is of course the longest side in a triangle, which of course here is distance. So therefore your cos becomes d-lat by distance. That's your first formula. You don't have to memorize it, you know it already. The second formula, you can write tan of course. Now what is tan of course? If you see the above triangle, so tan of course in any right angle plane triangle is opposite upon base. So what is the side opposite to the course? The side opposite to the course is departure and the base is d-lat. We know that already. So we have tan of course equals departure divided by d-lat. And the third formula could be a sine of course, not very popularly used, but of course you can use it. There are no rules that you can't use it. Sine of course, sine of any angle is always the opposite upon the hypotenuse. So the side opposite to the course line is departure. So sine of course is departure divided by distance. Alright, it's always opposite, the side opposite to the angle in question divided by the longest side, which is the hypotenuse. So you've got these three formulas for plane sailing already and your job is done. The only formula that you have to remember and which cannot be derived from this triangle is departure equals d long multiplied by cos of m-lat. What is m-lat? M-lat stands for mean latitude. In some books it used to be called the mid latitude, But nowadays the term mid latitude is becoming obsolete. It's become obsolete for a long time. You call it mean latitude. Alright, now this is the plain sailing formula. Of course, the same formula exists for parallel sailing, but it's a bit different. Parallel sailing is sailing along the same parallel of latitude, so the same formula becomes departure equals d long multiplied by cos of latitude when it is parallel sailing, because there is only one latitude. Now in plain sailing, because there are two latitudes involved, and if I draw this here, you know that the departure is increasing as you go from the pole towards the equator. So the departure increases as a function of the latitude. You can say that, right? So the departure between the the meridians increases as you go from the pole to the latitude, and then again decreases from the equator to the pole, right? Imagine this to be the north pole and south pole. So departure is nothing but this is the east-west distance is the departure. This is departure. Now in plain sailing, you have more than two latitudes involved. So now you know that if you are sailing from one latitude to the other, the departure is not constant, right? The departure differs. So if I draw this triangle here, this will seem very different from this triangle here. So you can see the departure is not the same. So departure is increasing as a function of the latitude, and that is why you can, and because it is related to the longitude, you can remember this formula as that departure between two longitudes will always be d long multiplied by a function of the latitude, which is cos of m lat. Why will not write latitude for plain sailing is because there are two latitudes involved. So I need to use the middle latitude, the mean latitude of the two latitudes always. I cannot write latitude here. If it was parallel sailing, I will write latitude because it has only one latitude involved. Alright, so these are some of the tricks to remember the plain sailing formula. Now it doesn't matter in which direction you're going. In this time I went northeast. What if I was going northwest? I will measure the course from the north pole. Again, this would be north. This would be my position A. This would be my arrival position, position B. I will measure the course this way. This is my northwest course. I will call it theta. The vertical distance again becomes d lat. The horizontal distance becomes departure. And of course, the line joining A and B is always distance. This is my northwesterly course. Alright, if I have to go southwesterly, this is A, this is B, right? And I will measure it from the south pole this time instead of the north pole, because I am going on a southwesterly course. This is the south pole. So I will measure the course here. This is my southwesterly course, angle theta. Again, the vertical distance becomes d lat. The line joining A and B is the distance, and the horizontal distance is the departure. And similarly, if I keep going, I can go on a southeasterly course. This is my A, this is my B. I will again measure it from the south pole. This becomes my southeasterly course. My vertical distance is d lat. The line joining A and B is distance, and the horizontal course is departure, of course. Alright, so this is how it all works out for plain sailing. Now I will explain what is Mercator sailing and how you can derive the formulas for Mercator sailing. So I will write Mercator sailing here. To understand Mercator sailing and how you derive the formula, you have to understand that Mercator sailing is based on Mercator charts. And what is the principle of Mercator charts? Mercator charts has the meridians drawn as parallel lines to each other. They are parallel and they are equidistant from one another. So not only are they parallel, but they are equidistant from one another. This distance is equal to this distance and equal to this distance. Alright, that is the principle of the, so these are all longitudes and meridians, so they are all equidistant placed. Now because in reality, if you look at the globe, this is not the case. This is an assumption they have made. They have to adjust for this assumption. Alright, this is a wrong assumption they have made. So how have they adjusted for this assumption? What they have done is they have created a differing distance between the latitudes. So it's opposite to the plain sailing. In plain sailing, the latitudes are equidistant placed, but the longitudes are curved lines, but here you can see the longitudes are plane and parallel to each other, but the latitudes are placed at different distances. So you can see here the 10-degree south latitude will be here, for example. The 20-degree south latitude will be here. So you can see the difference between them is not the same. So the distance increases as you go towards the poles. So similarly, you may have 10 degrees north here, but 20 degrees north will be slightly at a different distance. Alright, so they have done this because they wanted to adjust for the assumption they have made for assuming that the meridians are plane and parallel to each other, and they are not curved lines. So before I go into Mercator sailing, you have to understand the concept of what is meridional paths. Meridional paths. Alright, I will also call them MP. Meridional paths. Now what are meridional paths? Meridional paths, and I'll use a different color of pen this time, they are the number of divisions from the equator to the parallel of latitude. For example, from the equator to 10 degrees north, there will be a number of divisions. These number of divisions is called MP. MP is always measured from the equator to the parallel of latitude. So from 0 degrees to 20 degrees north, you will have to count all the number of divisions which is there up to 20 degrees north. That will be the MP for 20 degrees north. Now these MP values you can get from the Norris table. The Norris tables has the values for MP as tables. Now there's a formula also to calculate the meridional paths, but it's a bit long and complicated. You can of course use a scientific calculator, but I don't go into that. To be very honest, I make mistakes when I use the formula, so I always like to use the tables. So now if you have to calculate the difference in the meridional paths, or DMP, between latitudes, you have to calculate the MP value for latitude A and find the difference from MP value of latitude B. Now why I said difference, and I have shown it here. Difference doesn't mean subtract. It depends on whether both latitudes are in the same hemisphere or different hemispheres. Now if both latitudes are in the different hemispheres, you will subtract the MP value, the smaller MP value, from the larger MP value. If they are different hemispheres, you will add the two MP values to find the DMP. Alright, so for example, let's see here the MP value of 20 degrees north was say 250 minutes, and MP value of 10 degrees north is 150 minutes. So to find the DMP between 20 degrees and 10 degrees north, I will subtract the two and I will get the answer as 100 minutes. Alright, this will be DMP between latitude of 20 degrees north and 10 degrees north. However, if it was 20 degrees north and 10 degrees or 10 degrees south, I would add the MP value. So if it was 20 degrees north and 10 degrees south, DMP would be MP of 20 degrees north plus MP of 10 degrees south. You will add the two values if they are different hemispheres. Alright, so now that you have figured out the difference of meridional paths and what is meridional paths, I can go back to what I was teaching you guys on how to derive the formula. So to derive the formula for Mercator sailing, assuming we are again on a northeasterly course, I will plot the position A here and I will plot the position B here, and I will draw these two lines here. I will draw the same triangle as that I drew for plain sailing, and I will name it similarly as well. So here we have D lat. Remember the difference in latitude. This distance here will be again distance, the line joining A and B positions, and this here will be departure. This is what I have taught you for plain sailing. For Mercator sailing, you have to remember, and what I showed you above here is, you can see the latitude scale is very different from the longitude scale. So if you are measuring distance along the latitude scale, it will be different from if you measure distance along the longitude scale. This is the lat scale and this is the long scale. So if you, in Mercator sailing, if you are calculating latitudes and values involving latitudes, the small triangle, and again assuming this is theta, this is the course, the small triangle will work fine. Alright, you can use the same formula. So you can, one of the formulas here is cos of course, which is cos of theta, equals base upon the hypotenuse, so that will be d lat by distance. The same formula as plane sailing. This is one of the formulas of Mercator sailing. Same as plane sailing. This works fine. Now as soon as you go into the longitude scale, or you have to calculate values that involve longitudes, you will extend this triangle, make it a bigger triangle, and this triangle becomes your Mercator sailing triangle, where the horizontal distance is d long. Why is it d long? Because we know that the meridians are equidistant placed from one another. The distance between them is the same. I can call them d long. It will no longer be departure. And the vertical distance will not be d lat, it will be dmp. Why? Because I know that if longitudes are plane and parallel to each other, the distance between latitudes will be differing from one another with respect to the difference in the meridional parts. So as soon as you see this, the next formula that you have to use is tan of theta, which is nothing but opposite upon base in plane in a trigonometry. So opposite is d long, base is dmp. This is the based on the bigger triangle. So as soon as you start involving values that involve d long or longitude, you have to use the bigger triangle. Otherwise you can use the smaller triangle. Alright, that's it. These are only two formulas that you need for Mercator sailing, and you can solve the questions of Mercator sailing. So whether you have a position, a course and distance, and you have to find the position arrived, or you have two positions, you have to find the course and distance between it, it's the same two formulas for Mercator sailing. Again, here you went northeast. Even if I go northwest, it doesn't matter. This is A, this is B, right? I will measure the course from northwest. I will extend this triangle further, make it a bigger triangle. This distance becomes d long, this distance becomes dmp. The smaller triangle remains the same. This is d lat, this is distance, and this is departure. Alright, so whether it's northeast, northwest, it could be southeast or southwest. I can draw a southeast diagram for you as well. You go southeast here. This is A, this is B. You do the same thing. You will extend it. And this distance, the smaller distance, becomes d lat. Remember, this is the plane sailing one. It's the longer distance that becomes dmp. That is based on Mercator charts. This is of course departure, smaller triangle, but the longer triangle or the larger triangle becomes d long, and this is distance. Right, assuming this is a southeast course. Alright, so I hope this is useful to you. So even in the exam, if you don't get the formulas, or you can't remember the formulas, or you're not really sure how to apply the formulas, just draw the diagram, guys. Just draw it and decipher for yourself. This will clear your concepts as well, especially when two distances are involved. You don't have to rely on anybody to give you the formula. You can cross check that you're using the correct formula, but make sure you draw the diagram, and then it's just a matter of using plane trigonometry, finding sine, cos and tan of the course values, and getting the formulas from it. Alright, so let me know what you thought about this video. Happy to answer your questions in the comment section. Please make sure you put a comment in the comment section if you have any queries, and let me know whether you liked this video or not. Thanks guys, and I'll see you